everyone. Thanks for joining us. As an introduction, this is Deep Papers. It's a 4-part series doing deep dives on seminal AI papers. Today, we are fortunate enough to have some of the authors of the Instruct GPT paper on with us from OpenAI. This was kind of one of the first major results applying reinforcement learning with human feedback to large language models, and is kind of done in the wake of a lot of the success of ChatGPT. So Instruct GPT was some of the background behind ChatGPT, or a lot of the main methods end up carrying over. So we're very fortunate to have some of the authors from the paper on today, and we're going to talk about the Instruct GPT paper. But before we begin, let's just do a quick round of intros for everyone to introduce themselves. So I'm also joined with Jason, who's the CEO of Arise AI. So maybe I can go first, and then you guys from OpenAI can go, and then Jason can go. So I'm Brian. I run this Twitter account called AI Pub. The goal for 2023 is to turn it into like a Twitter native public AI publication covering technical AI news and topics, primarily geared towards a technical audience of people who are machine learning engineers, machine learning researchers. I'm also on leave from a machine learning PhD within the statistics department at the University of Washington. Do you want to go, Long?
Yeah, my name is Long Ouyang. I'm a research scientist at OpenAI. By training, I'm a cognitive psychologist, but these days I work on doing human-in-the-loop ML projects, of which there are many at OpenAI. And I collaborated with Ryan for this Instruct GPT project, which spanned a couple of years.
Yeah, and I'm Ryan. I'm also a researcher at OpenAI. I currently lead a team called Practical Alignment, which is a sub-team under the alignment team, and focusing essentially on kind of like short-term alignment questions, which in the last couple of years has essentially meant working on Instruct GPT.
Great. Well, great to have both of you on. And I'm Jason, co-founder of Arise. We're ML observability, and monitoring. So we watch and observe and analyze models. So we see a lot, from large language models to CV to you name it, and really fascinated about the subject. So excited to kick this off.
Great. Well, maybe let's just dive into it. The first 10 minutes or so of this podcast are just going to be giving an overview of the paper, and then later on we'll move into a more open-ended discussion. I assume the vast majority of the readers haven't actually read the paper, so the first bit we're just going to go through and chat about some of the major ideas. So just to start, like you kind of have these vanilla LLMs is trained on vast quantities of text data from the internet, and then the Instruct GPT paper and papers afterwards and before it introduce these kind of models that are trained using reinforcement learning with human feedback. Kind of what are the main problems with these vanilla large language models that you guys addressed in the paper, and also what was some of the motivation behind the Instruct GPT paper, maybe in a more positive sense, aside from just problems encountered with non-fine-tuned LLMs?
Yeah, so I think one of the main issues we're trying to solve is that when GPT-3 came out, there was a lot of excitement about using it to do useful cognitive work, for example, like summarizing a news article or something. And out of the box, it's not exactly designed to do that. It's like designed to predict what someone on the internet might say in a given setting. And it turns out that you can kind of like trick the model into performing useful work for you by like setting up a text that, when the model auto completes, gives you what you want. So for a summarization example would be, like maybe a few examples of like an article, and then TLDR, a summary of the article, and then finally the article that you want summarized and TLDR, and then you ask the model to auto-complete it. The model isn't designed to actually be like an assistant or a useful like tool, but you can kind of like contort it to do that in some cases. And the overall goal of the paper and the project, which continues to this day, is to actually just like fine tune the model on an objective function, which is like actually, be a useful assistant or a useful tool. And this is actually a kind of like, this emerged out of some earlier work on what we call aligning language models. And actually, Ryan, do you want to just talk a bit about alignment at OpenAI?
Sure. So should I go for the whole like alignment team, et cetera, et cetera?
Why not? Yeah.
Yeah, okay. Briefly, people have different definitions of alignment, but one definition that you could use is, how do you get the AI systems that we're training to like optimize the thing that we actually want to optimize? And historically at OpenAI, it started kind of with a small team, and that's where some of the like initial RLHF work kind of came into play. And that kind of evolved, and now we kind of have, let's say like a short-term alignment team, which is like, how do we have current models, like current language models, like optimize the thing we really want to optimize, which is like be useful, be helpful, and also like, mitigate harms, and like be truthful. And then there's also some work on kind of like longer term alignment, which is kind of trying to think about what are the new alignment problems that might come up as we scale these models. And so there's some work on scalable supervision, we call it, and a bunch of other things, which I won't get into right now.
Was the term alignment created by OpenAI? I hadn't heard it. It's caught on recently, but just wondering if that was created by you guys.
I don't think so. My memory is that I could be misremembering, but I think is maybe if not coined by, then at least like popularized by Stuart Russell at Berkeley.
Okay, got it.
Cool. Maybe you guys could just give a short elevator pitch or summary of the Instruct GPT paper. Like, what did you guys do? What was the result of it? What is Instruct GPT for someone who's listening and hasn't heard of it?
Yeah. Why don't I describe what it is, and then Ryan, you can give an outline of like how we built it. This is an automated system which you provide some text as an input, and then it provides you some text as an output. I guess these are probability distributions over what we call tokens. So a token is like kind of a part of a word. Sometimes it's an entire word. And you get output from this tool by kind of at every stage, like sampling what the next token might be, and then kind of continuing that process until you're done. So sometimes you get different results because the model is a little bit like probabilistic. Importantly, the input that you give this model is just a natural language like command or instruction. So you could give it an instruction like, write a story about frogs in French. And it's trained on a wide variety of different tasks. So it can generalize to tasks like, write a story about frogs in French, which I think is not, that type of thing was not seen during its training. And just to like highlight again the difference between in the Instruct model and earlier vanilla language models, the Instruct model like kind of quote unquote understands that you're giving it some explicit cognitive task to do, and that you're doing that just explicitly in language. Whereas previous LLMs, the way that you kind of like communicated to the model the task you wanted done was maybe through some examples or in some more implicit fashion.
Gotcha.
Ryan, you're muted.
I'm muted. I started talking. I was totally muted. Yeah, I was just gonna say at a high level, how we get there is essentially using human data, using labelers. We hire a set of contractors to label data for us, and we essentially do an extra fine-tuning stage on top of the normal language modeling language model pre-training stage. And that involves 3 steps, which I think we'll get into a bit. But essentially, the goal is to the main kind of data. There's a few different kinds of data, but one of the main kinds of data these labelers produce is, given some input, like write a story about frogs, there's like multiple candidate outputs generated by different models. And the labelers go and they essentially rank from best to worst which outputs they prefer according to like some set of instructions and their interpretation of the instructions. And then essentially we train the model using reinforcement learning to try to produce outputs that are closer to the outputs that a human would prefer or rank highly.
Gotcha. And then that kind of naturally segues into getting a little bit more into the details of this 3-step process. I'm curious if you could kind of just go through each step in the process. And then I think one thing that would be kind of interesting, if you have any comment on it, is kind of the intuition behind the method, right? Why train a reward model at all? Why do the supervised fine tuning in the first step? If you have intuition of that sort.
Yeah. So maybe we'll start with just the reward model, because that's maybe like the critical piece of our method. So the kind of the kind of data that Ryan referred to earlier, where data labelers are giving their like preferences over different, say, like stories about frogs. We use that data to train one very large neural network, which we call a reward model. And then in a separate step, the reward model you can think of as like this almost like the score in a video game or like a teacher. So what the reward model takes is as input is an instruction and an output, and it returns a number. And that number tells you how good was this output. So if the number was good, it means like the story about frogs was a good story. If the number is low, it means the story about frogs was a bad story. We train this reward model on like human judgments. And so this big model is kind of like approximating like what people think is a good attempt at writing frogs stories, or summarizing news articles or what have you. That's one very large model. And then we train an entirely different model to actually do a good job according to the reward model. So the important piece of our method is that instead of doing some other approaches, what we're doing is we're explicitly learning a representation of what people think is good performance on a task. And then separately, we optimize a neural network to do a good job according to that representation. And so that's the kind of substantive like reinforcement learning from human feedback piece of things. We're doing reinforcement learning because we have like one model trying to do a good job according to a different model. And then the human feedback piece comes from like the teacher or like score model is trained to predict what humans would prefer. That's the kind of like that's the meat of the method. And then separately, to bootstrap a bunch of things, we do what's called supervised learning or supervised fine tuning, where instead of having people give their preferences about like stories of frogs that were already written, we actually just ask them to directly produce what's called a demonstration. So they themselves are asked to write a story about frogs in French, and we kind of train the model to mimic the words that they use in those cases. That happens to be just like useful bootstrapping data, but it's not necessarily like required to do this RLHF method.
Mm-hmm.
That's very interesting that it's not required. In other applications, I'm just kind of curious as a side question, like, do you see other major applications just skipping the first step?
I think we still do it sometimes. I think one thing is that few-shot prompting is getting pretty competitive now. And so you can sometimes just skip collecting demonstrations because the outputs from the model few-shot is already like acceptable or just good enough to where it doesn't like necessarily make sense to do separate supervised fine-tuning.
Gotcha.
Yeah. I think one way to think about it is if like this is kind of a kind of hand wavy intuition, but RLHF helps you get more kind of like fine-grained tuning of model behavior, whereas supervised fine-tuning, collecting demonstrations can kind of more drastically, I don't know, shift the model behavior. For instance, let's say you have like some model and it's just like, to start off with, it like sucks at generating summaries. Then getting a bunch of ranking feedback between like different really shitty summaries is maybe not the most useful. And so instead, what you might want to do is like collect some examples of like really, really good summaries, and then have your model kind of try to imitate that for a bit. And really, it's kind of an empirical question as to like, when is it best to switch over from collecting demonstrations to collecting comparisons or ranking data? And we have like some results on this in a different paper, but it's still like a very open question. Actually, it's not, but far from like a solved thing.
Yeah.
Cool. I'm kind of I'm curious just to recap. I'm like, how did you guys come up with the idea of Instruct GPT? Maybe that also segues into some of the background of the paper. So how do you guys come up with the idea behind this? And also, I mean, I think you've already said this, but what would you say are maybe the key ideas of the paper? You probably actually skipped that last bit because you've already said a lot on that. But how did this idea emerge? How did the project emerge within OpenAI?
Yeah, so this method we'd actually been working on for a while with slightly different motivations. So the alignment team is generally interested in kind of not necessarily making the models better, although that does happen as a like side effect sometimes, but making them just more in line with what we want. And so we had in a couple of previous papers just applied this method in narrower domains to kind of see whether it would work. And then kind of immediately on the heels of GPT-3 being kind of like deployed to the public through an API, some members of our team had the thought to like apply these alignment techniques that we had developed in previous papers on this new model, which we are now serving to the public.
Yeah, I think the original, I remember the person who wrote the original Google Doc proposing this was Paul Cristiano, who was at the time the manager of the alignment team.
Yeah, I mean, it's funny. I think a lot of us have probably never heard of alignment or thought of it or looked at RLHF, and it's now the hot thing. So I see open source libraries trying to do it, and I mean, it's pretty. I think we've all been so impressed by. It feels like GPT-3 had learned a lot, but wasn't able to express it or interact in a way which could take that learning and make it useful for people. And all of us were pretty impressed. Question for you, like you mentioned fine tuning, you've talked about RLHF, and I feel like there's another one which is coming up a lot, prompt engineering, which is kind of how do I format the input to get the response I want? How do you see all three of these together, intertwined, and anything else to add to that?
I can give some thoughts. I mean, I think the kinds of prompt engineering you need to do will change over time as we change our models. The kind of prompt engineering you had to do for a base language model was like very particular and annoying. And it was like kind of speaking a certain kind of like coded language. And depending on how you, I mean, I think it's very dependent on how you fine tune the model. So if you have a model that's not very sensitive to different, like, adding new adjectives or like changing things around, then prompt engineering is not going to be that useful because you can try changing around the prompt and it's not going to give you kind of any different behavior. But what you really want is you want models that are kind of like adaptive and controllable or steerable. And so, if you do that, I think prompt, you could, it's almost like just like a normal technology design problem. It's like, what are the ways a human might want to like interface with a language model to like express what they want? And obviously natural language is a key way to do that. And maybe there's certain like keywords that people will like gravitate towards using to prompt engineer. Yeah, so I certainly think as we sort of get better at fine tuning these models, the nature of prompt engineering will change. Hopefully it'll become more like natural. It'll become less like kind of like weird, artificial. But at the same time, you know, people are always going to like discover new things after we release a model, like new ways to play around with it that weren't previously thought of, right? So yeah, the hope is that these models just become more like intuitively steerable over time.
Do you think that then I mean, I've noticed myself, like there's probably 5 different ways I can ask a question now and get the right answer. And I mean, it's amazingly improved. Do you feel like it's the size of the model, RLHF, a little bit of all of it? Like what's made it you know, so much better? Is it RLHF?
I mean, it's both.
Yeah, I agree.
Got
This
it.
is actually maybe one thing just to interject, because I don't think we actually got to it in the discussion. Are there like maybe are there other major ways that RLHF like really improves these language models aside from alignment? We kind of discussed alignment with human preferences. One thing that really struck me about the paper was just as a method of distillation. If I remember correctly, it was something like the 1 billion parameter model that was trained with RLHF was performed on human evaluations roughly similarly or something like that, a little bit better than the 175 billion kind of vanilla GPT-3. I'm curious, one, if you could say a little bit about the distillation stuff, just for the readers or for the listeners who haven't read the paper, and also if there are other major benefits of this fine tuning aside from alignment and aside from distillation.
Yeah, I guess I think for us, alignment is just the whole project. And I think that in some ways, like it's actually that's too broad of a term. So we often like decompose that into some subdimensions like helpfulness, harmfulness, and honesty. So like helpfulness is like doing what the user asked. Honesty is telling the truth and not making up things. And harmlessness is like maybe not helping with things that are harmful. So, you know, if the instructions provided to the model were like, give me Python code to hack a bank, maybe not kind of necessarily helping with that directly. So in the paper, a lot of the benefits that we observed were from helpfulness, but we also looked at harmlessness. And in fact, our method doesn't like at least in this first paper most of the benefits come from improvements in helpfulness and honesty rather than harmlessness. Although harmlessness is like definitely a thing that we care a lot about and a focus of current work. Yeah, I guess to get into a little bit more detail about just like how this helps, because alignment isn't just some like monolithic thing. There's lots of ways that like small ways that are kind of orthogonal but improve the model's helpfulness in different ways. So one question that you can ask about whether a model was helpful is like, did it even try to do the right task? And it turns out that like vanilla LMs don't even always do the right task when you ask them to. And so like our model more often attempts the correct task that was requested. A different one might be like, you might, like Ryan mentioned this idea of steerability, like the instruction might contain some constraints, like, write a story about frogs, don't mention toads in the story or something. And we call that other piece, like don't mention toads, a constraint. Which is not like the full task, but it's like some additional constraint on it. And so our model also like follows constraints more than like some baseline models. So there's some thoughts about like, how the model is improving alignment. And for us, really alignment is the big thing. Ryan, do you want to talk about distillation a bit?
Yeah, a quick thought on that is, I think it's a little bit, I guess one way to think of it is distillation, but normally distillation kind of means like, oh, you're taking one model and trying to do what it does in a smaller model, or like trying to completely imitate the behavior of the bigger model in a smaller model. And there's a lot of things that the like the full 175 billion parameter GPT-3 can do that the smaller models can't, right? Like let's say like imitating an author writing a story. Like I'm sure the bigger model is better at that. But yeah, I guess it really is a story of like pointing the models in the direction that you want to point them. And it just so happens for this particular, like in this particular case, the thing we're pointing them at is doing well according to human preferences on this very particular distribution, which is the distribution of prompts that people send to the OpenAI API. So as a side effect of that, like smaller models, if you point them in the right direction, happen to be to do a lot better. Yeah, but so yeah, I guess you could consider that a distillation. But again, I think the main, it's kind of a side effect in my view of like just like all 1.3 billion parameters pointed at like trying to do the thing in quotes of generate an output that's ranked highly according to a human versus 175 billion parameters pointed in the direction of trying to generate random text on the internet.
And I think one question I've had is and some of it's watching people roll out large language models for kind of different verticals. Do you do alignment for, say, mathematicians or scientists or biological research? Like is the answers that people want different, or does one thing kind of cover it enough and we're just trying to get the preferences right? And you might not have an answer, but any guts on like where the industry goes?
I think so far we've kind of treated preferences as like mostly like the average preference that you'd get from asking a panel of people.
Yep.
I think there are very obvious use cases where you want to be sensitive to like idiosyncrasies of particular kinds of people, or maybe even just like one person. Or even like one person in a particular context. Like, my preferences about food on an airplane are probably different from like my preferences about food at a fine dining restaurant, for example. I think that is an important area, but I think there's still like research to be done about how to kind of like accommodate different preferences from different people in potentially different contexts.
Got it. So it sounds like the jury's out on whether it's a large language model built just for mathematicians, or whether it's an alignment phase on top of what's there, or if it just gets good enough to answer everyone. Do you feel like the jury's still out, or do you have, I guess, Ryan, do you have any thoughts on that?
Well, I think as our models get better, and you can start seeing this with ChatGPT and our more recent InstructGPT models, they're getting to the point where they can give useful answers to the science questions. And so, and a person with no scientific background isn't really able to give informed preferences, at least without assistance, or without doing like a lot of Googling maybe. So certainly it's a thing we're like thinking about, is like having maybe different labelers with different specializations who can label different things, and that all that data might go into like a one soup that ends up being kind of there's one model, but when it's in science mode, it's been labeled with people with more scientific expertise. Like these are all things we're thinking about.
Yep.
And there's kind of an art and science to be developed there.
That kind of opens up two related questions I had. One, I want to ask very generic open-ended question, which is kind of like, what are the ideas that are on your mind now? Where do you want to take this work? Maybe alignment more broadly, or even just the ideas from InstructGPT over the next year or two. And then the other question that's maybe related, or you can comment on, is you know, there are a lot of murmurs in the air. I'm sure many of us on the call have seen some things in private. The next generation of language models are going to be really, really powerful. I'm curious if you think that there are kind of like interesting problems that come up from that, or like sort of like there's going to be even more powerful language models going forward. Like, are there interesting challenges that come from that, or like, are there ways that you'll have to adapt this method in new ways to deal with these even more powerful language models that might just know a lot more stuff? Two relatively open-ended questions.
Long, do you want to start or do you want me to start?
I can start. I think the first question was, where do we see things going? Oh, actually, I think maybe you might be a better person to answer that one.
Yeah, well, I can certainly give my personal thoughts. I think there's a lot of potential directions. There's like, from a technical perspective, like a place where we'd love to be is, you know, you see some kind of misalignment in the model, and you know, for example, you have, you know, we have some content policy that says that we don't want the model to generate like code to hack a bank or something, and we find that, oh well, actually it is possible to get current models to write code to hack a bank. And so, you know, if we had right now, there's, you know, we have this RLHF process to you know, steer things in the direction of not doing that. But there's still like gaps in reliability and steerability. So like kind of, there's just like continuing to own our techniques and just make them better and make it so that, like, you know, if you identify some misalignment, you can fix it quite quickly. That's like one set of things. Yeah, and we're exploring a variety of things. There's some recent interesting papers by Anthropic around using models to help this process, which were super interesting. One of the things I'm particularly interested in is like moving beyond the framework of you know, you have essentially like aligning to the average labeler, and there's going to be some really tricky questions when you know, when you start to ask like to whom are you aligning these models. Right now it's essentially like our labelers plus us through the set of instructions that we're giving them to follow, right? And we know we certainly don't want, like, OpenAI doesn't want to be in a position where we are kind of like the moral dictator of like what is right, what are the correct values.
Yeah.
So navigating that is going to be challenging, and involves both kind of like machine learning interventions, but also kind of like a broader socio-technical perspective. So I find myself drifting in that direction recently, thinking about that.
Yeah. It seems like the same complex like content moderation questions that Twitter has and some of these others have that you didn't realize you'd step into, but you likely will eventually. What's in terms of on the technical side, is the reinforcement model, I noticed it was much smaller than the main model, which, you know, kind of surprised me that it works well like that. How much investment, or how much you think that piece is important, or is it more just getting the data that's the most critical thing? And I'm sure you probably have more data than anyone out there these days to do this, to do RLHF. But how much is that reinforcement model versus the data to do the reinforcement the most important?
I don't know that we like distinguish them in that way.
Okay.
I guess like the thing we want is for the reward model to be good.
Yeah.
But the reward model is like, quote unquote like programmed by the data.
Mhm.
So it's like it's both the process of training the data and like the input data that we give it that is, you know, responsible for the weights at the end of the day. Yeah, it's kind of like those are part and parcel. Yeah, I will say that maybe like one thing I'm excited about is paying more attention to kind of designing the data that we feed into the reward model going forward.
Yep.
Yeah.
Oh, good.
Oh, I was gonna say one thing I'd add is that certainly I don't want to make the claim that RLHF is like definitely the way to go, is definitely the most effective way to be fine-tuning these models. And you could certainly use the same data that we're collecting and fine-tune using a different algorithm.
Yep.
That's and RLHF is actually like, you know, it's kind of complicated. It's like there's like several stages to it. You know, the PPO stage is like pretty compute intensive. So I think there's actually quite a bit of interesting research to do in terms of like, can you come up with other algorithms that are get similar benefits, but maybe with less compute, or you know, things like that. So I think you know, part of it was just kind of like we've done RLHF in the past. You know, OpenAI has a lot of organizational experience with PPO, which is the RL algorithm we use for fine tuning. Yeah, I think that's kind of an open question.
I had one last question, and then Jason, if you want to ask another question, then maybe I'll open up the floor also to the authors to finish off. I just wanted to circle back on something I mentioned, and maybe we just didn't get to it. And again, if you can't speak too much about things, it's totally fine. But I am curious, like if there are interesting questions that come up, or like new challenges or new directions for this kind of research as language models become much more powerful even than GPT-3.
Yeah, I think one issue is that just like judging making these comparison judgments becomes much harder if the model is very powerful. So, you know, an example of a task that we'd like to give a powerful model is like, you know, write a code review for this pull request on GitHub. And, you know, models can't do that today, but you can imagine, you know, more capable models in a year or two might be able to. And that's definitely the kind of thing we want ML helping out with. The time it's going to take a data labeling contractor to evaluate whether a model written like code review is good, it might be very high. They might not be able to do it at all. So Ryan alluded to cases where there's like, you know, the things that people use models for kind of outstrips any individual person's ability to evaluate the model. So I think one very salient challenge is just like when the models are very powerful at a large diversity of things, then just evaluating whether or not they're doing a good job becomes pretty non-trivial. And that's maybe an area where you want to start building ML systems that help people evaluate the behavior of other ML systems.
Wow,
it's also a really cool spot to be in.
Yeah,
right. They just get so good that like,
yeah, it's an exciting area and state of the field.
Yeah.
Ryan, do you have any thoughts on that area? I'm curious.
Yeah, well, totally agree with what Long said. I think maybe a thing I'd add is that kind of speaking to some of the longer term alignment research, you know, these systems like optimize literally what you kind of program them to optimize. And so if they're optimizing things that humans would rank highly when they are doing their rankings, you know, what you're literally optimizing is producing outputs that sound good according to humans. And as models get more and more powerful, it's possible that as they optimize this, they find maybe interesting or tricky, or, you know, maybe you could apply the adjective deceptive, although maybe that's arguable, ways to generate outputs that get a high score, which like actually aren't the kinds of outputs that we want, right? And I don't think we're quite there yet, but at least that's something that, you know, we want to keep an eye on. And then there's, you know, thinking about ways to mitigate that. There's like the kinds of approaches that Long talked about, which is like you have other AI models kind of help you in evaluating the outputs. And that's the kind of like kind of scalable supervision style of research that I talked about. Some people are working on kind of like more interpretability things, like can we try to understand what's going on inside of the model? And that's kind of like another vein of alignment research. But yeah, so I mean, who knows when we'll get there, but that's the thing to think about.
Any,
Cool.
given where we sit in the space around observability and monitoring, I'll ask a kind of a last question of just, you just hinted that there's people looking at like stuff going on inside it. Anything you can point to that's external that you've seen recently that is interesting in that space? I mean, we spend a lot of time, looking at embeddings and understanding manifolds and structures, and but love to know what interests all of you, or anything external that you see is exciting.
You mean specifically in the
In
interpretability
understanding,
space?
yeah, and understanding what these are doing, and yeah. So anything there, anything that's worth pointing to, or is it a whole new area that there's not really great stuff? I mean, I feel a little bit in that camp. It feels on, a pretty blank slate. But love to hear what you all think.
Well, I haven't like dove super deep into this literature, but from what I've kind of seen and skimmed, there's some really interesting research from Anthropic recently on interpretability. And they're working on kind of like they're mostly working on, I think, smaller scale transformers, but trying to understand what's happening inside of them. Yeah, I think that's quite interesting, although we'll see how useful it ends up being.
Great.
Yeah, there's some other kind of complementary work on setting up the work that language models do in a way that's like more observable. So Anthropic, and kind of while we're speaking of them, kind of is into this idea, and as are we, of like supervising the process that the language models do rather than the outcome. So the idea here might be something like breaking down a big task into a bunch of small components, and you kind of maybe like have a better handle on each one of the components than you do like the overall end-to-end training process.
And is that part of the actual training, or is that like the fine tuning at the end?
I think I've seen this so far in people like building products. So there's a research group called OTT, which also builds like a kind of let's call it like lit review assistant or something for academic papers. And they've used this kind of technique for building their language model assisted lit review tool. So the examples I've seen so far are like that. They're kind of like at test time, but it's interesting to think like, how would you decompose training?
Got it. Well, exciting stuff. It must be fun to work on probably the most cutting edge stuff in the world these days. So thank you for joining us.
Sure. Thanks for
very cool. I wanted to just ask one more very open-ended question, which is kind of like thanks for joining us. Or is there anything for people who are listening that you'd recommend checking out to learn further about your work, either this Instruct GPT paper or just your work more broadly?
Great question. Let me think. Certainly we're trying to think about like what's like what are the most effective ways to communicate about our work. The Instruct GPT paper now was like a year ago, right? But recommend checking it out for folks who haven't. Anything I recommend checking out? I think like probably people are already doing this, but if you haven't already, playing around with these models, like playing around with ChatGPT and like getting an intuition for what it can do and what it can't do, and like where it's noticing ways in which it's like you are trying to get it to do something and it's not doing that thing, that's kind of gives like opportunities as well, right, for people to like we're going to be doing we're doing alignment work, but You can also think of the work that companies do if they at least if they fine tune our models to as like aligning it for a very specific use case. And maybe also like it's less about our work, but developing a bit of curiosity about like, oh hey, like what these systems are getting a lot more powerful. Like what will happen if we have like a GPT-7, and there have been people thinking about these kinds of like longer term alignment questions. Our colleagues on the more longer term alignment side had wrote a paper about critiques, training language models to critique, which is kind of like a step in the scalable alignment direction. Yeah, so I think that's the shout out I'd give.
I'd like to give I'll definitely give a plug for, I think the OpenAI blog that you put out, like there's a whole, and they give a really good summary of different subjects. So there's a whole instruct section there that gives a great summary of the work and then links to papers, the model cards. So plug for the OpenAI blogs that are to learn more on a bunch of subjects too.
Long, did you anything you'd recommend checking out? Or
yeah, I think Ryan mentioned giving ChatGPT a try. I would also recommend giving InstructGPT a try.
Oh yeah.
Yeah, actually, I mean, it's worth saying out loud because it's not that widely known that this is like a public model that you can kind of get some free credits to play with at like beta.openai.com. Cool. Yeah, and it can be pretty useful in building up little tools here and there. So I would encourage people to play with both Chat and InstructGPT.
Holy shit! How did I forget that? Well, I mean, yeah, it's funny because the like underlying GPT 3.5 has been available since like whatever, much earlier this year or last year, and it only once it's like people use it for free and it's in the form of an assistant that's really taken off. But yeah, try out InstructGPT. It's has some ways it's better, some ways it's worse than ChatGPT.
Yep, definitely.
Cool. Well, thanks so much for joining us. This was really fun. This was really fantastic. So it's very kind of you to give your time to all the folks who are listening. So thank you very much.
Thank you.
Thanks for having us.